Hello, and welcome to 7.2, Similar Polygons. Last class, we were talking about ratios and proportions, and that's going to show up all of this chapter. So we are going to see it today with similar polygons. As you remember, polygons are just a figure with more than three or more sides, okay? Now, similar does not mean the same. Even though it sounds like it, it does not mean congruent. Similar means we have two polygons that have the same shape, but, and I'm going to put not necessarily in parentheses, not necessarily the same size. Okay, so quick example. If I drew a triangle, okay, and I'm going to copy this triangle, these two triangles would be congruent. They are exactly equal to each other. But if I take the second triangle and I blow it up, these are no longer congruent. These triangles are actually similar because none of the angles actually changed, right? I did not increase or decrease the angle size. The size of the sides and perimeter have all changed. Now, it does not mean the second shape has to be bigger. You could also shrink it down. And you see this a lot in the real world. If you have a blueprint, let's say this first triangle is a blueprint, we, in the real world, would blow that up and construct something. Or if we have, let's say, a model car. If we have a car in real life as the first example, and we shrink it down so that we could make toys out of it, we make it significantly smaller, right? And that's how we use similarity in the real world. So, similar polygons use corresponding parts. And there's that word again, corresponding. Corresponding just means in the same position. So let's use these two triangles as an example. I'm going to shrink this down just a little bit. And let's give this a name. Let's go with our RAM and then BLE. And I'm going to actually put these angle ticks here. Actually, no, let's give the actual measures here. Let's do 50, 60, 70. Just so we have some values to actually work with. 50 degrees, 60 degrees, 70 degrees. Okay? And similarly, 50, 60, 70. Okay. Now, to write the similarity statement, we would say triangle RAM is similar, and if you notice, this is just the top part of our congruent symbol, except these are no longer congruent. So that's a little small subnote. This means similar, not congruent. Oops, there's a missing an L. To triangle BLE. Okay, and this is really important because we need to know angle R corresponds to angle B. Okay, so our corresponding angles are as so. Let's do this really quickly. Corresponding angles are angle R and B, angle A with angle L, and angle M with angle E. Now, here's also a small piece of information is that corresponding angles stay congruent. Okay? So if you notice, R is still 50 degrees, B is still 50 degrees. Angles actually don't change measure. The only thing that changes measure are the corresponding parts or corresponding sides. So corresponding sides are proportional. And we'll talk about that later. Okay? Corresponding sides are proportional. okay? So if you took it, for instance, RA is not congruent, but it's similar to BL, okay? You could also follow through. RM is going to be similar to BE, they correspond, and then AM corresponds to LE. Wow, too many lines. So, being able to identify corresponding parts is just as important here as it was before. Now, if we actually gave measures to this, let's pretend this had a length of 3, this had a length of 4, this had a length of 5. Or let's actually use 4, 5, 6. Now, this is not a true triangle. Well, let's leave it another time. We'll say BL has a length of 12. Okay? And the way we're going to use this information is we are actually going to say this. Since RA is equal to 4, and then on the smaller triangle, oof, I should have used a smaller number. It's okay. BL is equal to 12. We're going to organize it as so, 4 over 12. So I personally like to organize it like this, like first triangle, second triangle, or bigger, smaller, smaller, bigger, however you want to do this. And we're going to create a proportion. So 4 over 12 is from left to right. And if you notice, let's say we want to find the length of LE. Well, we know LE corresponds to AM, and we need to find AM. AM is 5. And the reason why I put this on the top, because it is part of our first triangle. So LE is just an unknown. If we want to call it LE, we could. If we want to just call it X, we could. I'm going to go ahead and call it X. So if we just do some quick calculating, 4 times X is 4X. 5 times 12 is 60. Divide by 4. And X is equal to 15. Okay? Then, if you want to fill that in, we could. I'm going to fill that in blue, 15. And we could do the same thing with BE. We could use the same ratio, 4 over 12, from first triangle to second triangle. And we could say, well, BE corresponds to RM. So we could say 6 over, let's call this Y this time, because we don't want to use the same variable. We get 4Y is equal to 72. Divide both sides by 4. And Y is then equal to, I believe that's 18. I'm going to put that in blue also. And we have our second triangle filled in. Okay? And if you notice something, to go from 4 to 12, you actually can multiply by 3. And the same thing actually happens from 5 to 15 and from 6 to 18. And this is what we actually call a scale factor. Now, scale factor is a ratio, a reduced ratio of 2 corresponding sides. And in this case, we could actually see it here. If we simplified 4 over 12, so 4 over 12 actually simplifies to 1 over 3. That means for every 1 on the first triangle means it's 3 on the second triangle. If that makes any sense. For every 1, let's say, inch on the first triangle means it's 3 inches on the second. So let's call this first triangle, second triangle again. And there is your scale factor of 1 to 3, or times 3. If you want to view it that way, you could also do just times 3. So that's what we call a scale factor. Scale factor, where it is a reduced ratio of 2 corresponding sides. Now you could also view it as 1/3 also, just to taking a look at this. If you want to look at from left to right, to go from 12 to 4, you divide by 3, and that's pretty much what 1/3 is anyway. You take 1/3 of something, you're pretty much dividing by 3, okay? And then lastly, you could also do this in terms of perimeter, the scale factor. So if you look at this example, 4, 5, and 6 add up to 15. So the first triangle's perimeter is equal to, 15 units. And the second triangle's perimeter, if you notice, 12 and 45, 12, 18, 15 make 45. And we actually get that exact same scale factor, 1/3, when you simplify these. So this is our scale factor. Scale factor, okay? And we're gonna use this a lot. This is gonna make it a lot simpler if you could see this relatively quickly, but if you could always trust on your proportions as well, okay? So we'll definitely get some practice in. If you have any questions, please let me know, and I'll see you in the next one. Bye.